Have you ever wondered what the fourth dimension looked like? We live in a three-dimensional world, so our brains aren't built to picture a space beyond length, width, and height. But mathematics gives us tools to stretch our imagination. In this video, we will explore one of the simplest and most powerful ways to visualize the fourth dimension: analogy. Let's start from the basics. Imagine a point. It has no dimension, so it's a 0D object. You can easily imagine a point, but just one point might be boring, so let's add another one. Now we have 2 points, and what if we connect them? We get a line, which is a one-dimensional object. If we draw another line, and we connect those 2 lines, we get a square. And if we draw another square, and we connect those squares, we get a cube. Are you getting it? Every time we duplicate the shape on screen, we get a figure with a higher dimension. Now, if you are watching this video, you are probably doing it on a screen, which is a 2-dimensional surface, which makes everything even more complicated. But with some imagination, we can duplicate one cube to get 2 cubes and connect every corner. We've thus created what's called a tesseract. So here it is, in front of you, a 4-dimensional figure. But since you're looking at it in your 3D world on a 2D screen, everything is deformed. Therefore, observing a 4-dimensional object is impossible. But here the question arises: why? Why we can visualize such a figure? Imagine you are a 2-dimensional being living inside a flat world, like a character drawn on a sheet of paper. If I show you a cube, you wouldn't see it the way I do. Instead, you would only see a projection of it, a shadow on your 2D plane. Since your world doesn't allow you to fully see the third dimension, you would only see a square. The same happens to us. When we look at a tesseract, we are like those 2D beings. We can only see its projection, a kind of shadow of the 4D object into our 3D world, and everything on a 2D screen. That's why it looks so unfamiliar. At this point, someone might suggest a shortcut. We've talked about the 4th dimension, but not necessarily a spatial dimension, so why not consider time as 4 dimension? Indeed, reasoning this way reveals that the universe itself has 4 dimensions, 3 spatial and 1 temporal. And so we might say that a cube in a 4th dimension is simply a cube evolving in time. However, there are some problems with time, such as the fact that it moves in only one direction. And generally speaking, when we talk about the 4th dimension, it is assumed that it must be spatial too. So in general, even if we cannot fully visualize a 4-dimensional object, using analogy we can have a quite good representation of what it might look like.